So we are Blackbox. I'm Noah.
I'm Will.
I'm Randy.
I'm James.
I'm Jay.
Lucas.
So our main mission is to design a program that generates collage art with minimal human involvement. And here are 4 examples of collage art. As you can see, collage art is made by pasting images onto a canvas and then use those images to create a more cohesive picture. So our concept revolves around parametric design, which is basically design a program where the user gives the program a set of parameters, which is data, and then the program gives back an output. So in our case, we're giving the program reference images, how big each patch of images should be, and how sensitive it is to color changes.
And so one thing we wanted to do is limit human interaction with the program, and so we also designed a program that generates collage art entirely on its own using completely random shapes, and it also detects patterns from previous pieces that it has created to influence the next pieces.
Okay, for the social context part, we're gonna explore the human artist and computer artist. And we created a tool for human artists to explore beyond the collage art.
So our overall concept was inspired by previous image processors. For example, there was an app that took a picture and created a hand-drawn sketch. And then the AI generation part was partly inspired by Robbie Barrett's experimentation with AI portraits. So here's our project proposal. We have 3 main stages: image search, image generation, and auto image generation. The first 2 parts work together to create a collage art from the reference image, and the third part creates collage art on its own.
And can you guys imagine if human need to recognize many colors in a huge amount of picture will be really tired, but for our computer algorithm will be much easier. So we split to 3 content. First is find the colors in reference, and then we'll connect to database, and at last we'll search our connection for corresponding composition images.
We need to find all the color in the reference image. To do this, we go to each pixels and record the RGB color. We then group similar color together. For example, the light blue will be group the blue, and the gray will be group dark gray.
So after finding the colors in the reference image, we are going to connect our program to a database. Initially, we tried to connect our program to the internet, and we have succeeded in doing so by using a kind of Python package called urllib. But later we found that this process would be super slow because we have to download thousands of images every time we use the program if we do so. So later we decided to connect our program to a local database.
Okay, in this part, we'll use local files. And in this part, all we need to do is find a path that to our folder contains all of our images. And then we'll find the access that can get into our images and its content. Also, in this part, we'll find and compare average color. And as you can see, the example diagram, they have 2 colors. And we'll find the sum of each pixel RGB value and measure the average. And in this diagram, the average is light blue. And if this color matches the initial reference image, and we'll use this to part of our collage art.
So the second stage in our program would be image generation, and it contains 2 steps. The first one is to identify the patches of color, and the second one is to paste our selected image onto the collage.
Okay, so first, the computer runs the BFS algorithm. For example, if you're looking for a blue patch, it will identify a blue pixel, and then it will search the area around the blue pixel. And if it identifies the other blue pixels in the image, it will run algorithm again and repeat the process until it identifies all the blue pixels in the image.
So now we are going to paste our selected images onto the collage. And first of all, we need to create two identical bounding boxes on the composition image and onto the generated collage. And then we are going to match all the pixels in the two bounding boxes. For example, in this slide, we're going to match the left top pixel in the first bounding box with the left top pixel in the second bounding box. So all the pixels in the two bounding boxes will coincide.
And so now we get into auto image generation. So what we've been talking about up until now is giving our program a reference image that it makes a collage out of. But we really wanted to see what would happen if we totally took the human out of the equation. And so we created a second program to make abstract art on its own that we could then feed into our first program in order to make abstract collages. And the way we did that is I learned a programming language called processing, and I wrote a program that places primitive shapes along parabolic paths. And these parabolic functions give basically an x and a y value, and it places a primitive shape at that of a random color at that x and y value. And these parabolic functions are based off an increasing variable that I called t.
The second way to generate collage art on its own would be to use deep learning, and the specific algorithm is called GAN, or generative adversarial networks. Essentially, GAN uses two algorithms, the generative and discriminative. I'm going to call them G and D for short. So G creates an image, feeds it to D, and then D evaluates how close the image is to real collage art. So then it gives its evaluation back to G. G tries to make a better image, and the loop keeps going until G can make similar collage art. And now this is what we think the impact of our type of work will be. So in the future, we hope there will be a new category of computer-generated art, where art will be essentially contained in the world of quantitative data, so comp sci and math.
To sum up, there are three main steps in order to create a program that generates collage art almost entirely on its own. And the first one is image search. The second one would be image generation. And the third one is auto image generation.
So now for our discussion, we have three main questions. The first one is creativity simply a collection of inspiration? Because if it is, then GAN is essentially emulating human creativity, because the discriminative algorithm takes data from millions of previous collage art pieces to create its own piece.
And in my opinion, I still consider our program as an extension of human creativity because it shows its creation, but all based on our human developed algorithms. And if someday a super AI develops algorithms on its own without we human beings' interference, then I may consider this kind of creativity as genuine AI creativity.
And for our third discussion question, we discussed that what is beauty, and we discussed the answer is for most of the people we follow the fashion or the trends. That's the beauty for most of people's eyes. But however, still need to depend on the general public perspective.
So now we have two ideas for possible applications. The first one is to create attention-grabbing graphics, because what collage art specializes in is its high level of detail, and because there's so much detail and contrast, the human eye naturally goes towards the collage art. So if you put this type of art on like brochures or posters, for example, we could grab more attention.
And in some cases, some artists may think that making collage art will be complicated and messy. So if we have this program for human artists, will be more easier and can decline the risk and still can enjoy making collage art.
So finally, we have one last thing to ask you guys, and we want to see if you guys
Wait a sec. Actually, I was inspired by the sci-fi movie, The Ex Machina, we saw last week. And I know that whether computer has creativity is controversial, right? So I was thinking maybe we can do a test to prove that computer has creativity. Okay, keep going.
Okay, anyway, for those of you who don't know what a Turing test is, originally it was a way to test chatbots, and the way it would work is a human would have a conversation with something else, and they would have to figure out and discern whether they were talking to a chatbot or a human. And so we wanted to kind of adapt this test and to see if our program could pass off as human work. So there are 4 images on the screen right now, and if any volunteer would like to guess which one of these images was created by our program, I would love to get a couple guesses.
All 4.
No. Good guess, though.
Upper left.
Upper left.
Upper right.
Upper right. No. Well, I actually kind of tricked you guys. The person who said all 4 was actually the closest, because the only one that wasn't created by our program was actually the deer in the upper right. That was the only human-created image on the screen.
So now that we've seen what the output looks like and how we generate the output, here's an example of the program actually running. So as you can see, the program is putting on patches of images to create a cohesive image, in this case the bear. And now here's the collection of all the images we've processed so far. On top is the GitHub link to my account where you can see all the code that I've written.
Cool. Thank you.